In this week's In-Ear Insights, today we are talking all about large language models. Now, the ones you've probably heard of most are models like GPT 3.5 and GPT 4, which are from OpenAI, but there are many of these things. There is the GPT Neo X series from Eleuthera AI. There is Stable LM from Stability AI. There's Palm from Google. So there's many, many, many of these language models out there. And today we figured we'd talk about what they are, why you should probably know what they are, and maybe a little bit about how they work. So, Katie, where would you like to start?
I think we need to start with some basic definitions because you just said a bunch of words that basically made my eyes glaze over. And so I think we need to start first is what is a large language model? And before you give me an overcomplicated definition, let me see if I can take a stab at this in a sort of technical, see if I'm even understanding. So my basic understanding of a large language model is that it is basically like, if you think of like a box or a bucket and you put all of your content, your papers, your writing, your text, your data, whatever, into that bucket, then that's sort of like the house, the container for all of the language that you want to train the model on. And so, the more stuff you put in it, the bigger the bucket you need, hence the large, because you can't just have like this tiny little handheld bucket, have like 2 documents in it and say, okay, that's my large language model. That's not enough examples to give the model to train on. You need to keep giving it more information, and the more information you put in the bucket, the more refined you can make the model. Am I even close?
You've gotten the first part of the process of creating a large language model, but that's not what the language model is itself.
Yeah.
So, quick definition. When we say the word model in the context of AI, we're really saying software, but just like Microsoft Word is software, right? Or Candy Crush is software. A language model is just software. The difference is it's written by a machine instead of a person, right? Mostly people wrote Microsoft Word. Mostly people wrote Candy Crush. A machine or a whole bunch of machines wrote GPT-4. And because of that, it has no interface. It has no UI. It has nothing that is a human could use. It's like the engine of a car, right? You never, under normal operating circumstances, you never operate the engine of a car, right? The rest of the car interacts with the engine. You interface with like the steering wheel and the pedals and things. And so the language model really is the engine of these cool tools. And then the interface is something like a chat GPT. That's the rest of the car that you need to drive the engine.
Okay. All right. So a large language model is a piece of software built by a machine.
Yes.
But that doesn't really tell me what a large language model is.
Right. So to talk about that, we got to talk about language itself, because that's sort of the key linchpin of it. There's a quote from John Rupert Firth back in 1957. He's a linguistics guy, had nothing to do with machine learning, but he said, "You shall know a word by the company it keeps." Right? You know the context of words. So, for example, if I say the sentence, "I'm brewing the tea," right? You know what the word tea means in that context, right? You have the words I, that's the person, me, brewing, the verb, I'm brewing something, and the tea is the object of the sentence. If I say I'm spilling the tea, we know from jargon that really means gossiping, right? I'm spilling tea. It's not literally pouring a beverage on the floor. It is gossiping, but the spilling changes the meaning of the word tea, right? So we know a word by the company it keeps. And so a large language model is composed of essentially 2 things: the frequencies of words, and then the statistical relationship between words. So if I say the tea I'm brewing, right, that's a different sentence in English. It has a very similar meaning, but there the tea is the subject of the sentence instead of me. And so that's sort of the focus of it. If I say brewing I'm the tea, right, that makes no sense in English whatsoever. It's like, and that's a case where in another language like Irish, Gaelic, Hebrew, Tagalog, verb subject object structures are understandable. We in English don't understand this. So when you said you take all this text and you put it in a big bucket, that is the first step towards creating a large language model.
Okay. So do you have to pick a language? Like, do you have to declare like this language model is going to be English or this language model is going to be Spanish? Like, can you blend languages together and come up with a result, or does the model have to be like, okay, this version of the model is going to be the English speaking version?
That used to be the case. That is no
Okay.
longer the case. And the reason it's no longer the case is because of the architecture that's used to make large language models now. It's an architecture that is called Transformers, has nothing to do with the very cool 80s kids show.
More than meets the eye.
Essentially,
Got it.
essentially, this is what a transformer is. This is completely unhelpful for actually understanding how large language models work. But there's two things in there that will help us understand it. There's a section called input embedding and positional encoding. And let's talk about what these mean. Embeddings, software and computers can't read. Like, they have no understanding of words. What they can do is understand numbers, right? So if I say I'm brewing the tea, when a large language model starts being constructed, computers take all the words and all that text that you provided and start assigning them numbers. And what's important here is that there's numbers, right? But there's also position. If I say brewing I'm the tea, if that's in the text, the order of the numbers changes, right? That's what's called positional encoding, the position of the words. This is why you can have a language model that's multilingual now, because in general, Spanish words are going to be next to Spanish words. Chinese words are going to be next to Chinese words. In general, there are not many documents that are 5 languages at the same time, except for customs paperwork. But for the most part, books that are in Dutch are going to be in Dutch the whole way through. And so the probabilities of one word being next to the other word are going to kind of glue together to naturally form language, right? That's kind of how, so a model can understand. You would say, Je m'appelle Christophe would be French, and those words those frequencies would occur together, and the positions would occur together a lot. And so it understands, these things can understand multiple languages.
So three questions. 1, did you just insult me in French?
No.
Okay.
I said, my name is Christophe.
2, and actually, let me ask 2 and 3, and then I'll let you answer them. The 2 is, so it sounds like first you have to tell the machine what the sentence structure is meant to be so that it can then assign. And then my third question is, how is this numerical assigning different or similar to what we've come to know as like binary code, which is just ones and zeros?
So I answer that in reverse order. These eventually get converted to binary, right? We
okay.
just represent these as numbers.
Got it.
No, for structure, you don't have to provide language structure anymore. In fact, early efforts in natural language processing back in the 70s and stuff did that. They tried to create expert models teaching teaching machines the rules of language, and they were phenomenally unsuccessful because most of the time we don't use those rules very well. Right? True. It's a common joke, we in America, we speak 2 languages, English and bad English. It's mostly the latter. What is powerful about these tools and the reason they work so well is because there is no attempt to train them at all on structure. Structure naturally evolves from the way that we use language, right? So here's some reviews about tea, right? I like the taste and smell of coffee. I'm brewing the tea. I'm brewing the tea exactly the way they do. It tastes very good. The grammar's not great in some of these reviews, but this is natural language. And so what the computer is doing behind the scenes is it's taking those reviews and assigning the numbers and then looking at the probability that one word is going to be next to the next word, right? So the tea is a term that co-occurs a lot. right? That the probability of those two words occurring next to each other in these reviews is very, very high. I'm brewing the tea is a phrase that occurs a lot. And so the way these attention models work in transformers is they're constantly looking to see what is the relationship of a word next to the word next to it on either side, and then to the word next to that on either side, and so on and so forth, until it's essentially creating this very large, almost like the light from a lighthouse sweeping across text, understanding the words that are all around that word and developing mathematical probabilities that say, hey, if the word Starbucks occurs like 2 paragraphs up, but the word I'm brewing occurs 2 paragraphs down, these are still close enough that the machine would infer you're talking about brewing here. The next word's probably coffee because you mentioned Starbucks way up here, right? At no point did you mention oolong or jasmine, right? Something that'll be more associated with the words tea. And so that's what these large language models are. At their heart, there are big tables of probabilities, like a library of probabilities. This is one of the reasons why a lot of people who are talking about copyright infringement when people are training these models, what's in the model isn't your language. It's not your words. It is the probability distributions of your words and everyone else's words all blended together so that the models implicitly understand based on probability. If you're saying I'm brewing right, there's not too many options, right? I'm brewing tea, coffee, maybe beer, kombucha, probably not the fall of capitalism, but these are
Say more.
Exactly. That's how these models work. They are just huge tables of probability. And anytime you work with a tool like a Chat GPT, what it's doing, whether it's doing summarization, when it's doing, for example, generation, writing a blog post, the words you give it in your prompt help the model start to invoke what probabilities should I be looking at most closely. That's why the more detailed your prompt, the better it works because it has more probabilities to draw on. If you say, write me a blog post about dogs, right, you're going to get a real generic post of the most common probabilities around dogs. If you say, write me a blog post about how to properly train a Shar-Pei pit bull mix to retrieve items from the yard with a single command without using a martingale collar or a shock collar, suddenly there's so many more words in the prompt that can evoke the right probabilities for when it generates the text.
So I'm thinking back to a few years, probably at least 5 or 6 years ago when you and I worked at the agency and you introduced to our team this concept of topic modeling, which used natural language processing, which I understood to be the frequency and the nearness of words. So basically, we would create these clusters of topic modeling from a few different documents or a few different blog posts and say these are the topics that are being talked about the most and sort of give them a relative priority and size. And so it sounds like at a bigger scale this is very much the same thing in a more automated continual learning way, whereas the version that we were doing 5 or 6 years ago was a little more manual. Is that an accurate understanding?
Though what we were doing a few years ago was using much older technology.
Sure.
So it was technology that was essentially a mix of skipgrams and bag of words, which are essentially looking at just raw frequencies of words. But those older techniques could not take into account words that were a bit of a distance away. So it could understand I'm brewing the tea, right? And I'm brewing would be one pair, a bigram. The tea would be another. But it would have no idea about if you had mentioned Starbucks, 2 sentences ago. Today's models with things like transformer-based architecture are much more comprehensive. They can see, based on those probabilities, a variety of text, huge windows. For example, 3 years ago, the GPT-2 model came out, and that had an input and output of about what's called 1,024 tokens. A token is about a 4-letter fragment of a word, which translated to about 500 or 600 words, right? It could generate a paragraph before it went and just went off the rails. GPT-3 came out 18 months later. It could understand 2,000 tokens, right? Because that basically means the model got so much bigger that it could now see further in text. It could understand more text going in. It had been trained on more text and could create more text going out. GPT-4, which just came out a couple months ago, can understand 32,000 tokens in either direction. So you could put a novella in, right? And you could say, hey, turn this into emoji. And
Yikes.
It would have a 32,000 word business book in emoji, because it has so many more of these probabilities that it's been trained on that it can effectively do that. And next year's model, GPT-5, will probably be about 64,000 tokens. So you could take the entirety of our friend Anne Hanley's book here, just drop the whole thing in as a prompt, right? And say, rewrite this in Swahili, or rewrite this entirely as limericks, or turn Anne's book into song lyrics. You could do that with that big of a window because it understands so many more probabilities.
Okay, but back to my question, the topic modeling that we were doing is related. It's very
yes.
Okay, it's related because that was a concept that I understood. Basically, we took, I think you had used like a Shakespeare's play or something as an example when we were teaching it to the team, and said basically what this script is going to do is it's going to summarize the major themes from this particular, piece of writing. And so it sounds like this is a very early version of what now GPT is doing at a bigger scale, in a faster, more automated, like it's less manual intervention of you having to write the code and determine what like all of those like words are. Like that all happens behind the scenes now. Another example of this that we did was for a long distance trucking recruiter agency, and they had us take all of the transcripts from their interviews from their call center and turn that into that topic model. And so it sounds like in a much more efficient, much more accurate way now, these large language models could do that same work, but just better.
That's exactly right. The models now are capable of doing that in a much greater way, but it's still the same thing. So let's take a look here at this is ChatGPT using the 3.5 model. I fed it an episode of last week's podcast, and I said, okay, tell me the top 3 topics, and I want them isolated in a pipe delimited format. And so we've got these nice, topic 1, topic 2, topic 3. So now instead of having that crazy chart, which we used to make that with all the different bars and bands and colors, like, now very simple. It just spits out these basic probabilities about what this text is about. Now you can imagine it would be trivial to extract these percentages and then put them in a table. So you'd have maybe the blog post title, the URL, topic 1, topic 2, topic 3, and the topic 1 percentage, topic 2 percentage, topic 3 percentage for every blog post on your blog. And then you could start to use this information to say, oh, well, let's do a correlation between topic frequency using these new language models, which are much more efficient, and sessions, Google Analytics sessions, to say, what are our most popular topics? What topics bring the humans to the yard?
I was waiting for that. Thank you. I was waiting.
Exactly. But yes, it's the same concept now, just made a lot easier, a lot faster, and a lot more accurate by these large language models, where previously we didn't have access to them. They weren't something that we were able to do.
Okay, so I can actually see that kind of use case being really helpful for creating a social post. Like, hey, here's this really great blog post that we created. here's what it's about. You're going to get these 3 takeaways because this is what the machine told us this thing is about. It is about hourly billing. It is about, this, and it is about this. And that to me, I'm like, oh, great. I don't have to write social anymore. That's amazing.
Oh yeah, absolutely. One of my favorite use cases, in fact, this is an example that I do in one of my talks. Taking the 5-star reviews of my teacher's martial arts school off of Google, I fed all the 5-star reviews of the school, and I said, I want you to write social media ideas from these posts using the voice of the customer, right? So you and I have opinions about what Trust Insights is about, but we don't often think, okay, well, how do we write content based on what our customers say about us, right? And this is true of many businesses. Many businesses are like, oh yeah, this is what our value proposition. And if you read that customer feedback, kind of like what you're talking about with the driver's example, that's not what customers are actually talking about. So if you were to use customer data provided by customers, like reviews, with a large language model to generate content from that language, you would actually probably perform better because you're using the words and the topics that customers actually care about.
Yeah, that's that's an interesting, I feel like that's another topic for another day, but sort of the way that we think about how we're writing this content is like we're giving our perspective. We're telling people what we think they want to hear versus using the information that's readily available being said about us to create that content. I mean, that's just, something that the machines are going to be so much better at because they take out that narcissism.
Bias.
Yeah, for lack of a better word. Yeah. Of this is what I think people need to know about me versus here's what's known about you.
Exactly. And here's the thing, these models are good at 6 basic tasks, right? Generation, extraction, summarization, rewriting, classification, and question answering. Generation is exactly what it sounds like. Hey, write me a blog post. Believe it or not, this is the most popular usage. It's also what it's least good at. They're least good at that. Extraction and summarization, like extraction is pull this data out of here. For example, give it a list of 100 Twitter URLs and say, just give me the Twitter handles. Boom, done, easy. Summarization, simple, like we just did with that example from the customers with Instagram. Just summarize. Essentially, you're summarizing these reviews. Rewriting, another very popular one. Again, that one's pretty easy for these models to say, okay, I want to rewrite this in emoji or Sumerian, whatever. Classification, like what is this document? Again, very similar to topic modeling. And then question answering, like, hey, I need ideas for a blog post about this, and let's put these things out. What's interesting about these models, because of their architecture, they are better at what I call editing tasks like extraction, summarization, and rewriting than they are at writing tasks like generation and question answering. Because if we think back to what we were talking about at the very beginning of about this architecture, it's called a transformer. It is good at transforming stuff. So if you're providing all the data in that it needs, then what comes out should be substantially the same, but transformed. So the model doesn't have to work particularly hard to generate what you want to generate. You're just saying, hey, I want you to clean up the grammar in this post. That's a great use of these things, as opposed to write me a novel. That's not a great use of these things.
All right, so let me see if I've got this straight. So a large language model basically is a piece of software that takes, the inputs, the text, the content, the data, and does one of 6 functions, the functions that you were showing: generation, summarization, categorization, and 3 others. And then it basically says, like, what do you want me to do? And you say, this is what I want you to do. I want you to do one of these 6 things. And it does the thing. And it basically takes the text and the content and it turns it into numerical values. And it does the probability. What it gives you back is the probability of words that are the nearness of words, the closeness. And so in your example, I'm brewing the tea. it will say, okay, I know that I'm brewing means that this is the action that the person is taking, and the tea is the thing that they are doing. Um, so yeah, I need a little bit of time to wrap my brain around this so that I can better explain it back to you in a way that I feel like is a little bit more understandable. But I'm getting it though. It's complicated, but not.
Yeah, and the reason it's complicated is because these things use language differently than we do. Right?
Hmm.
They're not human. They are
Right.
mathematical machines. We don't use language that way. Right? We, even though our brains are neural networks, right? That's the OG neural network. It functions very differently in our heads than language does in a machine. And language for humans is actually relatively new in our evolution. It's a part of our brain that evolved relatively recently. So even for us, it's still kind of developing. That's one of the reasons why language can change so much, even from just generation to generation. I mean, there's all that '90s slang we grew up with, and nobody says anymore.
Yeah, it's a whole bunch of cringy language. It strikes me that sort of like it's along the lines of you having an idea in your head, but it not translating when you try to like write it down or say it out loud, because there's that missing piece of how do you get it from one place. That's sort of the same with writing these prompts for these big large learning models of what you want it to do, but unless you get the prompt detailed and exact, it's not going to come out.
Right. And so, we've done shows on prompt engineering and stuff, and we've
Hmm.
talked a decent amount about this stuff. The reason why prompt engineering is so difficult is because it requires you to know how your language works and know how the machine's language works and be able to do both, to essentially speak two different languages,
Hmm.
speak two different ways of using language. But if you get it right and you understand these capabilities, it's very powerful. Here's a fun one. If you were to write a LinkedIn request, those connection requests you get on LinkedIn that are usually just terrible, right? They're like,
Hmm.
I'd like to add you to my professional network, right?
You keep showing up as someone who I'm recommended to connect with. No, I'm not.
Exactly. What if you were to use a large language model? What would you put into that, Katie, to help you write a good connection request?
Oh, you're putting me on the spot. You know, uh, Help me write a authentic sounding, non sleazy connection to someone that I want to be connected with on LinkedIn so that they know that I'm not trying to sell them anything and genuinely just want to get to know them better.
Okay, I think that is a good start. Um, how would you make it relevant? Like, if you assume it, let's put aside um, technology and large language models for right now. Let's put that aside and just say, what would you do if you wanted to write a connection request to me?
Okay. It would probably be something like, hi, Chris, I really enjoyed reading. So basically, what I would want to do is I would want to start with why I'm reaching out to you in the first place and like what is relevant, not just a cold thing. I feel like there needs to be like a personal touch to it. Like, not just collecting numbers, but like, hey, I read your stuff. I thought it was really interesting. I want to learn more. So I was hoping that I could connect with you so that we could, talk about these things that you've been writing about or, whatever the thing is. And that to me is a more genuine connection and more likely to be accepted.
Okay, that's the approach that you would take with a large language model. So let's
Okay.
look at an example what this looks like. Go ahead and share my screen here. I'm going to say you're a LinkedIn expert. You know all this stuff, right? You're going to require a connection request. Here's me, right? I'm the person, the source of this, and I'm going to provide all of these words, which we
Hmm.
just discussed as the currency of large language models. And I'm going to take your background, Katie, your LinkedIn profile, bio stuff, and say, okay, write a connection request from the source to the target, emphasizing whatever common ground is available. So let's see what it does. right? So because of the language used, it's able to take what we provided, the source of the target data, and weave together connection requests. Now imagine this as a piece of software, right? Where it would have your bio as one of the prompts, and it would have just programmatically scrape the bios of the people you wanted to connect to over and over again and send customized connection requests that were worded as though I'd actually read your bio and knew what you were about, right? Instead of, the generic sleaze. But that's an example of how the language in a large language model works. The more of it you provide, the better it does.
Which makes sense. I mean, that's true of anything. So like, and I like to give the example of like, if you're talking to another human and you ask them like, hey, can you bake me a cake? And then you get mad because they bake you a vanilla cake and you wanted a chocolate one. Well, guess what? You didn't tell them. So just like humans aren't mind readers, these machines aren't mind readers, and they're not going to make assumptions about what it is that you want it to do. You need to be specific. I would need you to bake me a chocolate 3-layer cake with cream cheese frosting by 2:00 on Friday, and it needs to be gluten-free, dairy-free, no coconut, no peanuts. Probably gross and tastes like cardboard, but that's besides the point. But I've then gotten very specific about the instructions. And so then if it's not delivered correctly, that's a different conversation. But unless I give you all of those details, you don't know that that's what I'm thinking.
Exactly. Put this in your heads, folks. A prompt is a creative brief. Right? You would never hand a designer, make me a logo. Right? We'd never do that to a designer. You would be very specific. Here's the tone. Here's the emotions. Here's the colors we want to use. A prompt is a creative brief, and a large language model is nothing more than a coworker who needs a lot of specificity to generate the best results. Right?
That's true.
So to wrap up, a large language model is a piece of software. All models are software written by a machine. They are built on the probabilities of lots of language in ways that understand not only the importance of language, but the structure of it as well. They can write okay, they can edit better. And the results you get are directly proportional to the amount of precision and information you provide in. Again, like all computing, garbage in, garbage out. If you've got some prompts that you want to share or some questions you have about large language models yourself, why not pop over to our free Slack group? Go to trustinsights.ai/analytics for marketers, where you and over 3,000 other human marketers are all wondering if we're still going to have jobs in a month. And whether you are watching or listening to the show, if there's a platform you would rather have it on, the show is available. Go to trustinsights.ai/TI podcast on most networks that have podcasts. Our new YouTube podcast is up on our YouTube channel. If you want to check that out, it's at trustinsights.ai/YouTube. Thanks for tuning in, and we'll talk to you next time.